Welcome to the second video, which covers section 1.2, Use Segments and Congruence. You should be on pages 9 and 10 in your packet to take notes. Taking a look at our objectives, up at the top, we have two of them. The first one is to find segment lengths using betweenness, and the second objective is to determine whether segments are congruent. First, I want to have a quick discussion on line segments and betweenness. Line segments we learned yesterday. Just as a reminder, portion of a line with two endpoints. As a reminder, you should be writing down what I write down. So, two endpoints with a part of a line in between it. So here's a line segment. Now think about betweenness. If I gave you this line segment and I asked you to place some point between the two endpoints, what would you do? Well, you would probably put the point somewhere on the line segment so that's located somewhere in between those two endpoints. So this is what we're going to be doing today, using this concept of betweenness. So we have this postulate 1.6, which is the segment addition postulate. It says if 3 points A, B, and C are collinear, remember that collinear means they're on the same line, so our 3 points above are collinear. B is between A and C. Okay, so B is our point in between of A and C. Then AB add BC gives you the entire segment AC. So that's a little complicated way of writing it, but all that this is saying is you can add two parts to make the entire segment as a whole. So if you're still confused, that's okay. We're going to do two examples together. So I'm going to move this so we can see examples 1 and 2. Okay, so example 1, it says we are given segments RS, ST, and RT. What's important is S is between R and T. So I'm going to draw us a figure. S is somewhere between R and T. We are told RS is 3x minus 16. ST is 4x minus 8. And then RT, the entire segment, is 60. Okay, we are asked to find RS and ST. In order to find those two, we need to find what X is. Using the postulate above, the two segments, the two little segments added together, are equal to the entire segment. So in this case, RS add ST, the two parts, are going to be equal to RT, the entire segment. So I have 3x subtract 16. I'm adding the segment that's 4x minus 8. That's equal to the entire segment, which is 60. 3x and add 4x is 7x. Negative 16 and negative 8 is negative 24. It's going to be equal to 60. If I add 24 to both sides, I have 7x equals 84. Dividing by 7, I end up with x equals 12. Okay, but remember the question asks us to find RS and ST. So RS is going to be 3 multiplied by 12, subtract 16. So 36 subtract 16, which is 20. So RS equals 20. ST I can find in two ways. I can do the same thing, I can substitute again, or if the entire segment is 60 and this part is 20, what do I have to add to 20 to get 60? Well, I have to add 40. So that means that ST is 40. Okay, so that was example 1. Looking at example 2, it says AB equals 25. Find the value of x. So I'm going to mark that in the figure. AB is 25. Okay, what I want you to do right now is pause the video and try this one on your own. When you are finished, come back and I will tell you the answer. But you need to pause the video and try this one on your own, please. Okay, hopefully you paused this and took the chance to try it. You should have gotten x equals 8. Substituting that back in, AN equals 10 and NB equals 15. I am not going to be showing you the work. If you got that one wrong, take the opportunity to go back and retry it. Tomorrow in class, I will be checking to see that you have both of these problems finished. Moving on, we are now talking about congruence. Okay, congruent segments have the same length. So segments we can measure in feet, inches, centimeters. If two segments are congruent, they have the same length. They're both 7 feet. They're both 12 inches. They're both 3 centimeters. So we have a little important point about notation. If you ever see something like this, so we have an equal sign, and then we have two segments, but they don't have the segment bar, this denotes the actual length. So if AB was 7 feet, so we would have 7 feet is equal to CD is also 7 feet. That denotes length. This symbol right here, the equal sign with the little tilde, denotes congruence. So putting a line over the top, this is actually referring to the segments. So this notation is saying A, B, and C, D are congruent. They have the same length, but we don't actually know what that length is. All we know is that the two lengths are going to be the same. Okay, now we have example 3. It says find two segments that are congruent. This means two segments that have the same length. Okay, so between x and y, x is at, it looks to be -5, y is at -1, this is 4. Between -1 and 2 is 3, so between y and z we have 3. And between z and w, 2 to 6, I have to add 4 to 2 to get to 6. Okay, two segments that have the same length. Well, I have xy, which is 4 units. That's going to be congruent to zw, which is also 4. So that's one example. Okay, that's not the only example. What about xz? Okay, so xz is 7. Is there any other segment in this figure that is also 7 units? Well, yw is also 7. So yw is congruent to xz. So that would have been another example. Okay, so if you look at your notes, we have 2 more examples to do, and then you have 1 to do on your own. So moving on to page 10, we have example 4. It says use the diagram below to find wx. So I'm looking for this part right here. From the segment addition postulate, which we did before, I know that if I take VW, which is part, and I add WX, the other part, I'm going to get the entire segment VX. Okay, VW I know is 37. WX, I don't know what that is yet. And VX is 144. Okay, so subtract 37 from both sides. I end up with WX equals 107. So when you come to class tomorrow, you're going to have a few examples like that. Okay, sorry that the numbering got a little messed up, that we have example 4 and example 4 again, but now we're doing the second example 4. Plot the given points, determine whether the segments are congruent. Okay, remember that every point is x comma y. So r -2 comma 3, I go left 2, up 3. That's this point right here. That's r. S is 2 comma 3, so 2, 3. This is RS, so I'm going to connect those. Okay, and then I also have TU. T is -3, 2 right here. T there. And then U is -3, -2, which is right here. Okay, so now it says determine whether they are congruent. Remember that congruent just means that they have the same length. So do these two segments have the same length? Well, because they're horizontal and vertical, I can just count the boxes. So from R to S, there are 4 boxes, so RS is 4 units long. From T to U, there are also 4 boxes. That is 4 units long. So we would say, yes, RS is congruent to TU. And I'm going to write they're both 4 units long. If we had 4 and 5, it would not be congruent. They have to be exactly the same length. Okay, so that was the second example 4. Looking to the bottom of your page, it says, did we accomplish the objectives? First, we found segment lengths using betweenness. So that was like example 1 where you had to draw your own figure and then add the 2 parts to be equal to the whole. And then we also determined whether segments are congruent, which is what we just did. We graphed and determined if they had the same length. Now there's an example to the right. I'm going to start you out, and then you're going to keep going on your own. It says, consider the line segment below where AB is congruent to CD. Okay, so AB, this one, AB is congruent to CD. Something that I didn't tell you earlier in the video. To show congruence, we put a tick mark. That means congruent. So AB and CD are the same. I think there's a typo here. This is supposed to say AB is congruent to BC. Okay. Start over. I'm sorry, my fault. AB is congruent to BC. So if you could fix that on yours. AB is congruent to BC. Okay, so put tick marks here. Those are the same. CD is 3 more than twice AB. Okay, so that's a lot of words right there. We don't know what AB is. We don't know what BC is. Someone call AB X. Because BC is congruent, it's the same thing, I'm also going to call that X. CD is 3 more than twice AB. Twice AB looks like 2X, and it's 3 more than that, so add 3. And then you are told that AD is 23. And you are asked to find CD. This is where I'm going to leave you to finish the problem on your own. I'm going to check that you have finished this problem when you come to class tomorrow, and I'm also going to check to see that you have example 2 completed. I'll be checking your notes when you come to class. Thank you.